Okay guys, today in this video we're going to be doing moving on to the arithmetics unit, and first topic for that is going to be doing the work problems and the direct and inverse proportions. Okay, so now let's take a look on what we have here. Alright, so the first thing is we're going to talk about a direct proportion. And a direct proportion is when the two fractions that are equal to each other and the values are both constant. Well, we know what a proportion is, right? Is when two fractions are equal. Proportion equals to two fractions that are equal to each other. Two fractions that are equal to each other. Okay? We just need to know about what putting the word direct before proportion, what does that do to it? So direct proportion meaning that the values are constant. So what I mean by that is that when the input x increases, then input y will also increase. Alright? And then if input x decreases, then input y will also decrease. Okay? So now let's take a look at the right side over here, and we have the formula that's given, right? And in a given word problem, they might give you the y1, x1, x2, or they might not give you the y2, but they might give the opposite or vice versa. So you can construct a proportion from that by using this formula, y1 over x1 equal to y2 over x2. So say, for example, Joe makes $35 for 3 hours. How much money does he make in 1 hour? Okay, so that means I would be doing 35. Oops, let me get out my pen. Alright, so that means we're going to be getting 35 over for 3 hours. Then for 1 hour, how much money does he make? So that means when we're at that point, we are going to cross multiply like that. We're going to cross multiply. Give me a second. We're going to cross multiply, and we're going to convert that into an equation. So that means I would get 3x equal to 35. Then I divide both sides by 3. Okay, that means I get x is equal to 11 and 2/3, right? So that means he'll make about $11.6 almost per hour. So that means almost 11.67 if I were to round it. So almost $11.67 per hour. $11.67 per hour. Okay? Now, let's move on to the next one. Alright? So now, the next one is inverse proportion. And an inverse proportion is when the two fractions are still equal to each other, because we still have the, give me a second, we still have the proportion part. We still have this part, the proportion part. We just need to figure out what does this inverse part do. Okay? So then, it says an inverse proportion. An inverse proportion is two fractions that are equal but have unchanged values. So, that's what makes this a inverse proportion, right? The unchanged values. So, an unchanged value meaning that, like, if I have input x increases, then input y will decrease, and then also it can be vice versa, such as if x decreases, then y would increase, right? So, now let's take a look at this formula over here. And the formula that we have here is x1 times y1 equal to x2 times y2, right? This is different than the direct proportion, because you need to see when you're doing this type of problem, you need to see if x increases, does y also decrease, or if x increases, does y also increase. You need to think about the values as well, and then you decide whether to use inverse proportion or direct proportion. Okay? Alrighty. So now let's talk about this formula now. So again, the x1, y1, x2, and y2 can both correspond to what we talked about, the direct proportion. but in a slightly different way. So for example, it says if it takes 5 days for takes 5 days for 3 workers to paint a room, and then you might say how many days does it take for 1 person to paint the room. So that means you're saying that if it takes 5 days for 3 workers, how many days does it take for 1 worker? I'm going to put that as yen. Okay? So then I get yen will be equal to 15. It will take 15 days for 1 person to work. Okay? Now you need to think about it. Oh look, the more workers I have, the less days it will take. The less people I have, the more days it will take, right? That's why the values are unchanged. When the x increases, the y is decreasing. But if you look back here at our direct proportion, we said that the more time he works, the more money he makes. The less time he works, the less money he makes, right? So you just need to think about that as well when you're dealing with these type of problems. All right? Now let's take a look at the next thing, and now we're moving on to the example problems that we have here. So it says in 5 weeks John can make $1,000. How much money can he make if he works for 12 weeks? Okay, so basically let's think about this. Is this going to be an inverse proportion or a direct proportion? So this is going to be a direct proportion because look, the more weeks if you think about it, if you use common sense, you can think, oh, the more weeks he works, the more money he makes, right? That means the values are constant. So that means I'll be using the y1 over x1 equal to y2 over x2 formula, okay? So that means if I do that, then I get 1,000 over 5 equal to x over 12. So that means then I get 5x equal to 12,000. Okay? Now let's take out the calculator and figure out how much. So doing 12,000 divided by 5. So he would make about $2,400 if he works for 12 weeks. If he works for 12 weeks, okay? And that's how you would solve for the x value in this case, right? And also, if we know the 3 quantities, we can always find out the 4th quantity by doing the cross multiplication and turning that into an equation, okay? Okay. Now let's take a look at the second problem. It says 5 workers can paint a house in 10 days. How many workers are needed to paint a house in 8 days? So again, let's think about this. Is this going to be an inverse proportion or a direct proportion? Well, this is going to be an inverse proportion because look, the more workers I have, the less days it takes. The less workers I have, the more days it takes, right? So that means we're going to be using the inverse proportion formula, which is going to be x1 times y1 equal to x2 times y2, okay? So that means if I plug it in, then I get 5 times 10 equals to 8 times n. Then I get 50 equal to 8n. Divide both sides by 8. That means n is going to be equal to, let's see, 6 and 2/8. So you mean it'll be 6 and a fourth. So almost 6 and 1/4 days it will take. Sorry, 6 and 1/4 people, but we cannot have 6 and we can't have a quarter of a person working. So that means it'll take 7 people to do it in 8 days. Okay? Alright. Now let's take a look at the next concept that we're talking about, and that's going to be the work problem. So first, this has to be really related to the direct and inverse proportion because that's why I put it together as one complete lesson. Okay? So then, it says finding the total amount of time completing together. So that means in this type of problem, they'll give you how much time it takes for person A to complete the job working alone, and how much time it takes for person B to complete the same or similar job working alone. Then they'll ask you to find out how much time it will take if they work together. So in that case, you're going to be relying to this formula, which is going to be 1x plus 1y equal to 1z, where 1x is equal to amount of work completed by person A. Actually, I'll make this more simpler for you. I will say, let's say X equal to amount of time it takes person A to complete, and Y is going to be amount of time it takes person B, right? And then 1Z is going to be the fraction of the amount of work that is completed, right? So now let's combine it. Now that means if I were to do that, saying like if person A worked for 2 hours and person B can complete it for 4 hours, then how much do they work together? So that means I'll have 1/2 plus 1/4 equal to 1Z. Then you're just going to solve for it. You're just going to add them. So that means if I find a common, that means it will be 4. So that means this will be 1/4. This will be 2/4 equal to 1Z. That means I get 3/4, right? But then equal to 1Z. We want to figure out what Z is, right? So that means if I flip this, I also have to do the reciprocal of that. So that means Z will equal 4/3. Now, this is the amount of time it will take to complete the job. And 3/4 is the amount of time the amount of fraction of work that has been completed. So let me make that more clear. So I'm going to say 3/4 is going to be the fraction of work completed. Okay? Then 4/3 is going to be amount of time it takes to complete the job. Complete the job, okay? So that means also you don't want to leave this as a improper fraction. So that means this would be 1 1/3. Okay? So that means 1 1/3 hours they will complete it together. Okay? Alright. Let's erase all of that. Now, let's take a look at the next concept, and that is called undoing the job. And what I mean by undoing the job is that sometimes you might have a faucet that's filling a tub and a drain that is removing all the water. This is undoing your job, right? If you want to fill it, and then you have something that is undoing the job, right? It's draining. So, you want to figure out how much time it takes to either drain or fill something when both are open at the same time. So sometimes filling something may not always be your job, right? Also, another job might be draining it. So you had to see what type of job they're asking. So in this case, I'm gonna ask a simple. I'm gonna say valve. Let's say like faucet can fill a tub in 20 minutes. No, not 20 minutes. Faucet can fill a pool in, let's say, 2 hours, and a drain can remove all the water in, let's say, 1 hour. Okay. Then it says maybe figure out how much time it takes to drain to the tub when both are open. So that means I would look at this formula right here. So that means 1A minus 1B equal to 1D. But sometimes they might say one faucet can fill it, another faucet can fill, and then one can drain. So that means in that case you'll use this formula. But in this case we'll only have 2 things, so we'll be using the first one. So that means I'll say it takes 1/2 minus 1/1. So that means I get 1/2 minus 2/2. So that means I'm just made this up, so it's not going to be accurate. So basically you're saying -1/2. So it cannot be negative, but this came up as mind. This is the first thing that came up in my mind, and I'm just showing you how I would put this into the formula from a given problem. Okay? So now let's take a look at the example problems that we have here. It says Mary can paint a house in 5 days. John can paint the same house in 7 days. How many days can Mary and John both paint the same house together? So, basically we're going to be using the formula 1A